Greetings, everyone. I welcome you all to this interesting topic. So, even as I teach you this wonderful topic, I guess you are going to follow clearly, and everything that I'm going to say, you are going to understand them. So we've started this particular topic called metals. Is one of the major topics that a person needs to understand whenever we are looking at chemistry. This is an important topic, and I guess you are going to understand. So when you ask yourself, what is a metal? So when you've got this question, what is a metal? What do you understand by a metal? So whenever we are talking about metals, we are talking about elements. Elements that does what? That loses. So say elements that loses electrons. These are elements that loses. So elements that loses electrons for them to be stable. For them to be what? To be stable. That is a metal. That's how we get to define it chemically. So what is a metal? A metal is an element that is going to lose electrons for it to be stable. Hence they are what? Hence they are positively charged. Hence they are what? Hence they are positively charged. So we also need to understand that these ones are positively what? Positively charged. This is just an introduction, and I guess you are going to understand what I'm going to share with you in this short lesson. It's something that is so simple, something that you are all going to understand and enjoy. So I've told you to say that metals, these are elements that loses electrons for them to be stable. So for a metal to be stable, it must lose electrons. So once it loses electrons, it becomes positively charged. For example, you may have magnesium. Magnesium is like this. Have you seen? This is positively charged. We can have aluminium. Aluminium is like this. This is positively charged. We can have sodium. Sodium is like this. This is what? Positively charged. So these are examples of metals. All the metals are what? Are positively charged. So a metal is that element that is going to lose electrons for it to be stable. So for a metal to be stable, it must lose electrons, and losing electrons makes them to be positively charged. So the number of electrons they are going to lose, that's the charge that they are going to have. So this is something that is so simple, and I guess you are able to follow me clearly. Without wasting much of your time, I want us to start looking at what we get to call alloys. So I want us to start looking at alloys even as we go in details. So we are going to start with the alloys. What is an alloy? So you have to understand what is an alloy. Some people get to differentiate this or try to make some comparisons with the allotropes. No, those ones are totally different. So don't even think of those ones. So here, what is an alloy? What do you understand by the term alloy? So whenever we are talking about alloys, you need to understand that this is a what? This is a mixture. A mixture of what? A mixture of two or more metals. A mixture of two or more what? Or more, we say, or more metals, or I would say, or a metal, or metal with. So metal with a non-metal. With a what? With a non-metal. This is what we mean when I say an alloy. So an alloy is just a mixture of two or more metals, or metal with a non-metal. So a mixture of a metal and a non-metal, there is a way in which we can form an alloy. Quite all right, you understand that whenever we are dealing with a mixture, A mixture is a physical combination of substances. So each time we get to combine two or more metals, we get to form up what we get to call an alloy. So you discover that the combination of alloys is physical. This is a physical combination. So you have to understand that a combination, so I'll say a combination. So a combination of alloys, so I'll say a combination, you have to understand that a combination of alloys, that a combination of alloys is always physical. Is always what? Is always physical. This is something that is happening physically. So it is always what? It is always physical. This is what I get to mean. So an alloy, a mixture of two or more metals, and this one gets to be done physically. You discover that alloys are other than the metals from which they are made. This is a powerful characteristic or a property that you have to understand. So we have told you to say that alloys are what? Alloys are harder. These ones are what? These ones are harder than the what? Than the metal. I will say than the metals from which they are made. So from which I will say from which they are made. They are what? They are made. This is one thing that you have to understand. So alloys, these ones are harder than the metals from which they are made. So you are going to understand this very well when we look at examples. That's when you are going to see that, okay, so even this one is harder than, you discover that when we mix one or two metals, or when we mix two metals, we are going to form one alloy that we get to call brass. So you discover that the brass is, or a bronze is harder than the metal from which it is made of. So I guess you are able to see these ones are harder than the metals of which they are made. So you just need to understand them this way. And I guess we are all writing down notes. So I want you to understand that alloys, when we say arrowing a metal is one way of increasing its strength. So in terms of arrowing, combining metals. So when I say arrowing, I don't know why these markers are not working. Not so sure. So arrowing. So when we are talking about arrowing is another way. So what am I going to say? I'm going to say that arrowing of metals. So say arrowing of metals is what? Is one way, or one of the ways of increasing. So one way of increasing its strength. Increasing its what? Its strength. This is something that you have to understand. So whenever you get to combine one or two metals, or a metal with a non-metal, you get to form an alloy. And an alloy is harder than the metals from which they are made. So that process of combining these metals is another way of increasing their strength. So we are also doing what? We are also increasing their strength. So how is the preparation of alloys being done? How is this? How is it done? So we look at preparation of what? Alloys. How is it done? This same preparation of alloys. So let us look at some preparation of alloys. I guess you are able to write down everything that I'm teaching here. You are able to write down everything that I'm discussing with you. You are supposed to be following me. You need to make sure that you are able to follow everything that I'm teaching you and discussing with you here. So I said we look at preparation. So let us look at preparation. So I'll say preparation of what? Preparation of alloys. Look at preparation of alloys. How is it done? This same preparation of alloys. what are certain things that a person needs to understand. So you need to understand that when two metals are mixed, the mixture is usually heated under controlled temperature. So when you do what? When you mix, so when you mix substances, these substances, since we are talking about alloys, they must be what? Let me say metals. It can be a metal with a non-metal. So in general, I'll just say when you mix, these are metals, like substances. So when you mix them, then the mixer, then the what? Then the mixer, discover that, then the what? Then the mixture is, then the mixture is heated. So say the mixture is heated under what? Under controlled temperature. So I'll say under controlled what? Controlled the temperature. This word here is temperature. You can finish it. So under controlled temperature, temperature gets to be involved. Now, after heating these metals, they get to melt. So once they undergo this process of melting, you now discover that the molten mixture is then allowed to cool and solidify. Once they solidify, it means that they were in molten state where they get to combine. Once they are combined, they get to form one thing. So after letting them undergo a certain kind of temperature which makes them to melt, you are going to discover that the molten, so we say that the molten mixture, so we say that the molten mixture is then allowed, to cool and solidify. So is then allowed to cool and solidify. So this is the preparation of what? Alloys. And you need to understand this. It's just like a simple preparation that you have to understand. Like a simple, I guess you are even able to see this simple preparation of alloys. It's something that is so simple. And I want us to look at some of the advantages. So we look at the advantages. So let me say advantages. Advantages of what? Alloys. What are some of the advantages of alloys? These are things that you expect in an exam. And these things will even come. So the most important thing is understanding the concept. So one of the advantages is that these ones, when we form alloys, when alloys are formed, you are going to discover that they are flexible in use. So we get to say one, let me use, I'll say they what? They are flexible. They are flexible in use. So they are flexible in use. Two, we are going to understand that they usually have an improved appearance. They usually, so I'll say they usually, so I guess we are able to see this. They do what? They are usually, so I'll say they usually have an improved appearance. Have an improved. So they usually have an improved appearance. They get to have an improved appearance. So I will say appearance. You can finish up that. That is appearance. So they usually have an improved appearance. Aside knowing that, you also need to understand that these ones also, they are what? They are, so I will say they are reliable. Reliable and what? And durable. So this is what you have to know. Reliable. I've already told you that they are harder than the metals from which they are made. These ones are hard. You discover that they have increased an increased resistance to corrosion. You discover that they don't last that much. Where they get to form rust, no. So the fourth one, these are advantages. If I tell you, give me two advantages of forming alloys, discover that they have what? They have, so this last one, I'm going to say that they have. So let me say that they have, so I'll say they have increased. They have increased resistance. Increased what? Increased resistance to what we get to call what? So increased resistance to corrosion. This is something that is so good, something that you have to understand. Let us now look at the examples of these alloys. Even as I'm teaching, I'm also giving you notes so that you are able to follow me clearly. So no one should say I was not writing, and I've already told you I don't mark when you submit work on a paper. You are not supposed to even submit. So once you join this school, this is a school, so you need to make sure that you are doing everything according to the rules that are here. You are not supposed to write on a paper, submit on a paper. I'll just be putting my X. Just know that there is something wrong with your work. You need to make sure that you've submitted in a book. I think most of you, if not everyone, when you were starting, I told you that you need to have what? You need to have a book specifically for, if it is chemistry, for chemistry. If it's physics, physics. If it's mathematics, mathematics. A book is just 20 kwacha. So 20 kwacha, you'll be using that book till you write your exams. So we need to make sure that if you've not bought yourself a book, please make sure you buy a book that you are going to be using. Let us look at some examples of alloys. This is the last part. We are done with the alloys. This is like a simple topic. We've just finished this in, this is 16 minutes, so even less than 20 minutes we are supposed to be done. So let us look at the examples. Examples of what? Examples of alloys. What are some of the examples of alloys that we are supposed to know? Those of you that have just joined us, you are saying, I think we are behind. How can we catch up? You are not even supposed to worry about anything. As long as you are here, as long as you are connected, even as we get to move, you are going to catch up. All those things that you think you are behind in, we are going to cover them. What I can just tell you, be committed and serious. Make sure you are attending to each and every lesson that I'm doing. Let us now go to examples. The first one that we are going to look at is brass. It is like this. This is an alloy that is made up of a certain composition. So what makes up brass? We've got copper. When copper combines with what we get to call zinc, we get to form what? We get to form brass. This is an alloy. These are two metals that get to combine together to form that. So this is what you have to understand, something important that you need to know. So you discover that the percentage of copper is 70, but the percentage of zinc in that, it is 30. So just to give you a composition, this is how they are. So discover that in brass we've got more copper than zinc. What is the use of this? Mostly it is used, brass is mostly used when we want to make musical instruments. So this one is used, I would say, used in what? So I would say used to do what? Used to make musical instruments. Used to make musical instruments. So used to make musical instruments. This is what I'm going to say. It is used to make what? Musical instrument. So that is what you have to understand. Its particular property is that it is harder than pure copper and it is resistant to corrosion. This is what I told you. Most alloys are resistant to what? Corrosion. So if I tell you, okay, give me a particular property of brass, you discover that it is harder than what? Pure copper. This one is harder than pure copper and resistant to corrosion. So if you can forget this, you can also write down. We move now to the next one, which is bronze. So we move to bronze, which is like this. We move to this part that is here. So when we are talking about this, which is an alloy, and I've told you that an alloy, which is a combination of metals. So this one, what are two substances that get to make up bronze? We've got the copper is there. We've got copper. Aside copper, we also have tin. So when these two combines, we get to form what? We get to form bronze. And here we've got high percentage of copper, which is 90%. But tin is just having a smaller space, which is 10%. So you discover that these ones are harder than pure copper. And mostly, whenever we are talking about bronze, this one is used if we want to make metals. I guess those of you that have gone for competitions, you discover that used to do what? They are used to make those things. Like a metal, I think you know this. So they are used to make what? Metals. I think you know those metals. So I'll say used to make medons like this. Then they are also used to make what? Aside this, it can also be used to make a trophy. So I'll say trophies. So how do you write trophies? I'll say trophies like this. This is how it is, like this, trophies, yeah. So it is used to also make what? Trophies. Something that is easy. So these are alloys. This is an alloy. This is an alloy. Another alloy, there's what we call milled steel. Milled steel. So this one is made up of iron and carbon. It is made up of iron. This one, it is made up of iron and what? And carbon. These things, you are supposed to know them. And how can you know these things? It's by studying. You discover that in here, we've got the iron. I'm giving you these things so that you know that the percentage of iron that is in here, it is 99.7%. This is just 0.3. This is just 0.3. You now discover that this one is stronger and harder than pure iron. Here we are now talking about iron and the way this one is milled steel. Where do we use this milled steel? You discover that it is used in making what? In making boiling tools. Let's say we want to make some crushing equipments. They are also used to make automobile bodies and parts. So they get to be used in so many ways. Just to list a few, I'll say they are used to make what? These ones are used to make so I'll say making what? Making bridges. They are used in making what? Bridges. We can use these in making bridges. We can use them to make what? I'll say making, so let me say making what? Making crushing equipments. Crushing what? Equipments, in making crushing equipments. So say crushing equipments. Aside this, you also need to understand that they are also used in making automobiles. So I will say automobile what? I will also say automobile bodies and parts. Automobile bodies and parts. We get to use that one, and parts. Aside knowing this, so I guess you've seen this, and let me give you time now to write down this so that we get to move together. We are supposed to be moving together. So I believe you are writing down these things. You are able to understand them. You might not know the actual percentage, but at least you need to know that, okay, this one, it gets to contain more amount of iron. This one gets to contain this amount of copper. This one gets to, at least you need to have a picture of these same things that we are dealing with. So when we are talking about this, you understand, okay, there is a high amount of this in this thing that is here. We need to understand it that way. So let me continue with some examples where I guess some of you've heard of stainless steel. That one is a common one now. That one is a common one. Stainless steel is very common. So it is a what? This one, it is an alloy. It is an alloy. So what I'm going to do is this. So let me say this is a stainless. So I'll say stainless. So stainless steel. This one, it is an alloy. This is an alloy. Made of what? It is made of iron. It gets to contain iron. Aside this iron, it gets to have nickel. So it gets to have nickel and chromium. It gets to have chromium. So these are the three substances that get to be involved in stainless steel. In that, this one is used in making some laser braids, small things here. Used to do what? Used to make those simple things. Laser braid. We can talk over a knife. We can use this. So how do you knife? Like this, isn't it? If I'm not mistaken, how do you write the word knife? So making knife like that. So I would say knives like this. Making a lot of that, because these ones do not what? Do not rust. So the reason why we use that, because they do not what? They don't. So I'll say they don't rust. This is what I'm going to say. The last one is soda. I guess you know it. Like this one. So this one is also an alloy that is made up of tin and lead. Tin and what? Tin and lead. Maybe you want to know the percentage of these ones that I listed here. This one gets to carry 70%. This one carries 20%. This one carries 10%. When we move to the last one, here you discover that this is 50-50. Have you seen 50%, 50%? So we've got the equal amount in that one. And what is it used for? This one mostly it is used for soldering. I guess you've heard of like a soldering wire. I guess you've heard of those things, isn't it? Those of you that have gone that area. You discover that these ones, a solder has got a lower a melting point than either tin or lead. So you have to discover that this one gets to have a lower melting point. It has got a lower melting point than this same than the lead and the tin that is there. So this one has got a lower melting point. And I want you to understand that. So I'm telling you that this one has. So you need to understand that it has a what? It has a lower. It has a lower melting. So I would say it has a lower melting point than what? Than tin. So I would say than tin and what? And the lead, like this. It is used to make what? Soldering. This one is so simple. Soldering wire. Those of you that maybe your phone was not working properly, they had to maybe get the panel in your phone, had to put to my wires like that. So there is that wire they were using. I think you've seen that. So these ones, they are in types. So they are used in what? So used, I'm talking about this one. It is used in what? Used for what? Used for soldering. It is used for soldering. I would say used for soldering and welding. So used for soldering and welding. This is where we are going to end from. And I guess you've learned one or two things. You've learned one or two things on alloys. And I don't expect anyone to fail a question that may come in an exam. So before you even answer the exercise I'm about to give, you need to make sure that you do what? you've studied these notes for a minimum of 10 minutes, even 5 minutes. These are simple things. So before you answer the exercise, to maintain and keep that information, I want you to study through these notes for about 15 minutes. So we study through for 15 minutes. We just make sure that we've understood the concept and everything that is here. Everything is in studying. Let no one lie to you. Everything is in studying and revising through. You discover that you study through, your brain will keep this information. Even if you forget, you will still be able to remember some stuff that, okay, at some point I had to learn this. You will still be able to remember. Iron, when we are talking about stainless steel, iron has got the highest percentage, followed by nickel, which is 20. Then lastly, we've got chromium, which is 10. And when we go to soda, you discover that soda, which is an alloy, gets to have 50-50 with tin and red. So you say, okay, lead 50, a tin also 50. So this one, it means that it even has a lower melting point than tin and what? Lead. So this is where we end from. I guess you've gotten one or two things here. You've gotten some parts, and I guess you are going to do better even in the exercise that I'm about to forward. Thank you.